Dr. Tremante received both his BS and MS in mechanical engineering from Simón Bolivar University in Venezuela and his PhD from IMCIC in Paris, France. He remained there for postdoctoral studies in multi-phase flow and pumping applied to nuclear and oil industries. Presently, he teaches courses in thermodynamics and fluid mechanics STEM of the BSME program. Dr. Tremante began his stint at Florida International University working as a senior research scientist with the Applied Research Center before moving to the Mechanical and Materials Engineering Department in 2009. Prior to this, he was professor and head of the Mechanical Energy Conversion Laboratory at Simón Bolivar University from 1992 to 2005, where his undergraduate and graduate courses and research areas included thermodynamics, fluid mechanics and heat transfer, statics and dynamics, thermal and hydraulic turbo machines, internal combustion engines, energetic systems, hydro and thermal power generation, fossil and renewable energy, oil production, and multi-phase flow. In the recent past, he has been an editorial member of several journals and has published 75 papers in his area of expertise. So thank you, Dr.
Thank you, Bill.
On behalf of the International Conference on Complexity, Informatics, and Cybernetics, I would like to thank you all for being here and Dr. Cloud for this kind of invitation. And when he talked to me about the topic, just to share with you a little bit about how do we correlate, how do we put together academia and two different concepts, which is academia in this case and the professional sectors, either public or private. Sometimes it's difficult to put together two concepts that maybe they are opposite, but they complement each other. And trying to explain or to share with you a little bit how do we do this, I picked up an example, which is a case study that we have the opportunity to work back in our country. How do we integrate, in this case, academia and professional disciplines? And by the way, I picked up, obviously, that example because, well, I had the opportunity to work with that along up to 6 years. And this is a creation, a baby from Dr. Cloud when he was back in Venezuela around 1984, 1985.
Yes.
But it was 1884, 1885. Okay. So when he was the founder, by the way, of this concept, and he put together all the different goals and objectives of this foundation. And something that I would like to highlight that we were talking about it this morning is, going to the previous slide, is exactly this. We said, okay, how do we correlate these two concepts using a not-for-profit organization? As long as the university, the academia, is already a corporation with its own rules. And sometimes this type of relationship with the surroundings is not that easy. And it's not that easy because, well, faculty from different disciplines, they could see this type of integration or correlation in different ways. Engineering standpoint could be completely different from science standpoints and so on. And trying to put all this zoo together was very difficult and try to different actors with different disciplines and different length to look at the same problem. And once again, was not that easy. When I was in charge of it, and I shared that example with them this morning, when we tried to come up with a project, whatever project it was, obviously, as a university or as a foundation, say, well, we have some overhead. An overhead for administrative purposes or financial purposes or so on. And they say, well, why that overhead is so high, even though that overhead in the United States is about 45%, but back in Venezuela was between 10 and 15%. But even though it was too high for some people. And I said, well, yes, that's true. We are a not-for-profit organization, but at the same time, we are a not-for-losses organization. I mean, we cannot lose money, okay? Because if not, this is a baby that won't even grow up. Will die before he can even walk, okay? And that's where, just with few words, the big picture of the first problems that we had when we tried to come up with this new concept. So maybe that answer is already, that question is already answered, and the answer is two things that I would like to share with you very briefly. You say, well, what's FUNINDES? Why is that exactly the case I would like to share with you? Well, the first one is because it's basically the objective, the title of it is Research and Development Foundation. And here I would like to highlight the word of, because this foundation belongs to that university. It's a son or a daughter of it. And I wanted to highlight that because right now I have the opportunity to work at the Florida International University, and since 5 years ago I've been working very close to something similar, which is the Applied Research Center. But the Applied Research Center, even though I could say they are twins, they are similar, but they are not identical. They are not equal. They work in different ways, and I'll try to explain that later on. And here I'm highlighting something that is here the word of, which is the vinculation of that foundation and the university, and here the same thing. Here we have a center, a foundation, and that works at Florida International University. The way they link each other, it's different. The answer to the question how is different. Even though, like I said, we could say that they are twins, they are similar in the same objective, same goal to put together academia and industrial or surrounding areas. So briefly, like I said, the foundation was created and established and really started in 1986. And the basic idea of this was that a small organization was able to put together the academia here, okay? Basically professors and students, not only professors, that they belong to different teams, different disciplines, like I said before. So we try to come up with a platform of multidisciplinary and interdisciplinary worlds, okay? And put together all them to work through the university for the industry, for the country, for public and private sectors. At the same time, like I said, it was a structure, was an organization with its own legal personality, and that's very important. That's the main difference between this organization and the one that we have here in the States, the one that I've been in touch at FIU, because the Applied Research Center doesn't have its own legal personality. It belongs inside the academia sector, and everything, every dollar that goes in and out has to go through the university. In this case, even though I said Research and Development Foundation of, if you remember, wait, not even here. Stop. Let's wait a little bit. Even though I said before of and at, and I highlighted those two words, here the main difference is that there, and we still have the same organization that has its own structure, which I would say, if you ask me what's the advantage of it, I would say, well, it makes easier the process of understanding and agreement and engagement with the sector, with the surroundings. So we could sign, in 2 words, a contract in less than 48 hours. Okay? So we don't need maybe days, weeks, and months until we reach an agreement. Because if we need months to do it, maybe once we are ready to sign, already the opportunity already passed. Because, well, we need to sign in 2 or 3 days, no more than those hours, and then we took maybe months to do it. So we were able to move much faster than the university usually does. And obviously allowed at that time self-financing, okay. Self-financing of the foundation. And once again, we had a sort of income that it happened when we had a kind of emergencies in the university. Once again, the foundation belongs 100% to the university, and we have not only our own board of directors, we have a board where the university said, okay, let me see your financial aspects, let me see what you did last year. We meet each other 2 or 3 times a year, and then we have to sit down with that board and let them know as a university what are we doing. And sometimes, like I said, with certain emergencies, we could give money to the university to do things that happen. For example, if some of you maybe know, in 1999, between 1999 and 2000, we had a major crisis with a rainstorm. Okay, the university lost one of its campus around Caracas, and then we lost up to 15,000 square meters of structure, and then there we were able to help, financially speaking, some of the aspects that the university have, these type of things, okay? And finally, once we have that flexibility, we were able to have a better idea, better knowledge of the surroundings of the university and how do we connect with that sectors, the public and the private sectors, by, once again, by consolidating multidisciplinary teams, different interdisciplinary approaches, taking into account that that world was made of thanks to professors and students. I hope. I think I have to restart the computer. It not works. I'm very sorry about it.
Before you do that, I think you just need to click on the presentation.
Yes?
There you go.
Okay, wonderful, thank you. Okay. Oh, you saved my life. I appreciate it. Okay, so here, I won't use this. Here, the next step is, okay, once we have set all these characteristics and items and advantages and disadvantages of one world and the other world, how do we put together? How do we do it? Then, for us, the main question is, well, how do we do it? How do we improve as an organization? In few words, how do we set up that platform, that environment, as a multidisciplinary and interdisciplinary collaborative research across the university? So we have our systems, the university, and then how do we really get in touch with the surroundings, in and out? How is the energy flow? How is the mass flow? How do we go across the university? That was when we did some focus group, not only inside the academia, but with the industrial sector. I would say that this small quote is the one that really was like a main conclusion. This is a kind of paradigm that we needed to face and change. It was a dynamic paradigm. Maybe 10 years ago, our across was completely different from the one that we have nowadays. By the way, nowadays, you all know that we have a political crisis, and maybe the case study that we have here has on top of that another boundary conditions. Okay? But in reality, what happened at that time, even though or regardless, which is very important by the way, the political crisis, the word across or trying to answer that question, how do we do it, was the main challenge of this problem. So I wanted, at the same time, I wanted to share with you the mission. The mission of this type of corporation was mainly working with professors, research, engineering, and scientists, trying to, once again, solve real problems, face engineering problems around the world. And when I say around the world, it's because our university is the academia is the world, and then just out those boundaries, okay? Could be local problems, regional problems, national problems, or international problems. So in that case, we were trying to work engineering, science, technology through research, through teaching, engage our students as well. And then FUNINDES is the window between academia and industry worlds. And here, when I highlight the words engineering, science, and technology, and maybe I will add another one that is not here, which is mathematics. Nowadays, all of us, we have heard the word or the concept STEM, which is science, technology, engineering, and mathematics. And during this morning presentation, Dr. Ward's presentation, he mentioned something that I read years ago about Picasso, when he said that art is alive. I understood that, or I knew about it, maybe in a different approach. I understood that art was alive to avoid reality. Was something that it was inside art, trying to not to get in touch with reality. The way you shared with us this morning was, no, well, art is alive that will open the real truth, the capital truth. And then I'm sharing with you that example because right now at FIU we are trying to change the word STEM with the word STEAM. And you say, why STEAM? Well, maybe STEAM is a fluid, but it's very close to me. Why? Because I am energy engineer. I work very close to power cycles. And power cycles, one of the main power cycles has to do with water. And water is liquid and gas, and that gas is steam. And we work very, when I teach thermodynamics, I always keep talking about steam. And you will say, what does steam have to do with STEM? Well, what's the difference between STEM and STEAM? It's one letter, the letter A. And that letter A is because we are adding science, technology, engineering, art, and mathematics. Because sometimes when we read it just like this, anyone could ask, there's no art here? We don't need it? Has nothing to do with this? And maybe the answer is yes, obviously, it has to be here in the same way that maybe mathematics is not here, but it's behind all this type of sentences, words, concepts, quotes that you can read here. So I want to take this opportunity to share with you something that is ongoing, that we're trying to set up some grants or proposals about, start talking about STEAM instead of STEM. The vision of this is, well, it changed, like I said, due to the political boundary conditions that unfortunately we have in our country right now. But trying to keep the academia beside all these problems was always trying to lead our university in the international world, trying to have a problem based in real world problems, engineering real world problems, and have our students and professors and researchers and experts working through that window in a way where they can keep in touch. Keep in touch means update themselves with what's happening around the world, and maybe the problems that I share with my students in my lab, in my office, in my classroom, is not something that I think it should be. It's something that I have a feedback that is always giving me information, maybe on a mobile platform, like our previous presentation, where I keep updating information, and that information is powered, is very useful, and I share that information with my students, and not only teaching this always the same things, which they don't change. When you teach mathematics, or you teach basic engineering, basic mathematics, or basic science, the equations that are there, they have more than 100, 200 years ago. They are there, they will be there. But when we try to apply those equations somewhere, that's the way it should work, and that feedback is extremely important in that sense, in order to lead our organization to an international world and as a window, as a market problem where the university could acquire, manage, and execute relevant projects. And once again, I want to highlight it's a real world problem. You will say, well, what areas of expertise? Maybe what I will share with you here, like I said, are engineering areas that we can start working together in a multidisciplinary and interdisciplinary way. For example, in our university, we don't have the typical faculties or colleges or departments. We have, for example, we don't have the mechanical department, or we don't have the chemical department. We have the fluid mechanics and transport phenomena with thermodynamics. We have energy conversion, which works electrical and mechanical engineers together. We have the fluid mechanics and transport phenomena that I told you, that fluid mechanical and chemical engineers together. So the matrix organization is slightly different in order to allow us to work in a better way facing multivariables problems. Nowadays, we don't have a problem with one-dimensional variable. We have problems with multi-variable, multi-dimensional problems. And the structure that the university already had gave us a huge opportunity to set up that window and then start working with the surroundings like I explained before. And I would like to finish with this slide, maybe going back to the first question. How do we do it? How do we set up that platform? How do we set up that environment to work? University, academia here, and the industry. So one way to do it is come up with vectors of communication around knowledge. How do we put together maybe, and when I try to, I said, well, let me just come up with a slide, one single slide to explain what I would like to share with you. Look, these two areas are not touching. Maybe they are completely different. They do not overlap. We have no intersection between them. And I drew these two areas like that because I said, well, they don't get in touch. Worst case scenario, they don't get in touch. But they will get in touch through something else, which is we share knowledge. And once we share knowledge, okay, using the latest technology, any mobile application, any other electronic system or mechanical system, old system, new system, what we're trying to do is share real problems around knowledge, and then once we learn the real problems, we put them back in the academia, we work with them, we research about them, we teach about them, and then we can come up with better solutions about some information that went from here to there, and so on. So we have, in 2 words, a never-ending process, okay? A cycle that goes back and forth, and the income here goes there, and from there there's an outcome, and so forth, that will allow us to work in a better way. Once we did it, nowadays, like I said, things are a little bit different, but look at the different organizations that we were able to work with. more than 400 by 2010. They updated in 2009 and 10. The updated information was more than 400 public and private organizations. This one here is the Venezuelan oil industry that was our major client. And then you can see national and international names like Chevron, like Petrobras, like American Airlines, and different others, the Italian oil company as well, where we were able to work very close with them. This one is just the county where the university was, is already there and was in touch very close to them at that time. And like this is a small example, what were we doing? And just to give you an idea, that flexibility allow us, the last time that I was there in 2002, we could work the amount of flow. Sometimes when I say cash flow or money, once again, money could be a concept that is against academia, but our budget, in terms of projects that we were working with in 2002, was equivalent to $11 million. That for that small organization, no more than 32 people, okay? Keep in mind, though that platform is just a window. The experts are not inside the organization. The experts are outside, are in the university. Where here in the US, the example that I gave you at the university and those that I also know from other universities, the experts are mostly not only the university but inside the same organization. So they hire the experts, and the experts are researchers and scientists or technicians that they work for the Applied Research Center. In this case, FUNINDES is just, like I said, a very small organization that its only mission and vision was put together these two worlds, okay, using knowledge as the main driven force. Thank you very much.
Thank you.
I hope